AI, what you can do with prompt tools and agents, in which I will have in three different sections. The first one is we will give a brief background into review of the large language models. So the core part of it is like it's practical, it's usable today, but it's no longer it's not a sci-fi robots, but more like a smart repeaters, and we'll explain why. Second thing is we'll introduce three level of using the large language models, which is prompting, tool use, and LLM agents. And they are like adaptively adding to each other, and like a ladder, we will just using like finally get LLM to accomplish very complicated task for us using the agent. And finally, we will give an example and with like incremental planning a weekend getaway to conclude the three level use as an example and give it a conclusion. So let's get started. First, what is LLM? So LLM is a type of AI trained and memorized vast amounts of text data. So if we're using it, we can type any questions we have in like a natural language, and it will predict and answer in human text, which make us thinking like, okay, I'm seemingly like very smart. It can answer something. It can give us information that we do not have knowledge of or cannot be thinking of in previous days. And on the slides on the left-hand side is the supply end. So basically, almost all of the leading tech companies in US and also around the world. This image just showing the US results. It's pairing themselves with some of the either LLM like provider or their special department working solely for this generative AIs. And so they are very like putting a lot of efforts and energies and also money, resources into this domain. On the right-hand side, the demand end, which means like the LLMs, if we view it as like we type questions like previous in former days, we're searching it for Google or any like search queries. Like LLM nowadays are having much traffic recently, and it's even like making the previous traditional search queries is getting lesser use, and LLM using is like straight down. So the demand is very strong, and supplies are also very strong. So it's a hot topic recently. And the in these slides, we want to know what are the core part of the LLM and to make me or make everybody know that they are not like self-consciousness or self-aware to like a rebel or whatever to take charge of like a human being like we have saw in like fantasy sci-fi movies. We can best thought LM as advanced autocompleters, which means that on the bottom side we have large language model training mechanism, meaning that, as I said, large language model are trained on massive amount of text. How they can train that? Basically, for example, in this image, we have a text called second law of robotics. A robot must obey the orders of given it by human beings. It's a text that we want LM to remember. Then the training mechanism will split it into multiple training sample. Each of them will be cutting the original text in, say, random order, not random order, random position. And they will force the LM or let the LM to predict the next word given the previous content. For example, if we cut it in this comma thing, column here, then the LM will predict what's the most possible next word given the previous second law of robotics. Then it will give you an A. And if we append the A to the previous generation, it will keep just iteratively predict next word. And in this example, if, for example, it predict incorrect word, for example, it would not saying a robot or saying maybe a machine. That's close but not exact word. The training mechanism will give LLM a small penalty, or which makes the LLM's parameters slightly change to make it more favorable of predicting the correct output instead of the previous one it just predicted. So a conclusion from this one is basically the training mechanism of the LLM is like next token prediction. It will iteratively give you next word based on the example or based on the input you give it. And this next word prediction capability is from the training on all the data it has been trained on. So nothing special. It is like a very smart or advanced autocompleter, but they do not have self-consciousness. And the source of trained data is of vital importance. Usually we have three kinds of training corpora. The first thing is like a web spelled the corpora, either like a scrapped from individual website or encyclopedic content like a Wikipedia, or they also have community forums like Quora or Zhihu. From this size, large language model can know some of the basic facts, saying like US capital is Washington, D.C., and China's capital is Beijing, something like that, or some quick question answers, saying like what the question, what is like a cup is made from, and it can say, okay, it can memorize they are like plastic cups, like a paper source cup, etc. And this from web scale corpora. Second thing is like published literature. Basically, we have also textbooks, journal articles, and scientific papers. Large language model are also trained on these to having more advanced, so the first bullet is more like in like a human, like a conversational language, but the literature is more like what was it, rigid a little bit, rigorous a little bit. They are like in deep, like a deep knowledge that can help like a more like a domain practitioners to advance their productivity. And third thing is like synthesis data. Synthetic data will be help LM to better form their results. So they are generated and annotated by LM themselves. But the purpose of having this additional part is not creating new knowledge, but more like aligned LM output, like it be more in favor of human preference. For example, we have the fact that say today's weather is sunny in Raleigh, for example, this sentence. If we train on this and remember this specific sentence, but we ask this question in another like in a slightly different way. Um, Without this synthetic data, I might just repeat the same answer with any no changes. But having the synthetic data can just adjust its response by like learning or like by adapting to the answer format. It can to better be instruct to follow human instructions. In the bottom, we have two examples. On the right-hand side, we have a good example of using LLM itself. And the right-hand side is, in my understanding, not a good one. On the left-hand side, we say like we're asking some factual questions, and I'm just asking it a like same question like we introduced in this slides. Basically, what are the being trained on, and it can give you three results like perfectly, even though a little bit disaligned with what I'm writing on here, but it can give you correct information. It might miss something. But if we ask a question that cannot be put into its training data, saying a future prediction of the weather or stock price or lottery, whatever, then LLM is haven't been trained on this information, cannot be give you an exact answer. However, they can give you some templated results. I would say templated, but more like they know how to answer given this uncertainty, but they cannot give you helpful information for this type of question. So long story short, we want to ask question that's having some specific pattern, more like static answers to LLM, which they are more capable of giving you like efficient results. And why LLMs matter, like we want to learn it, and just like the beginning of this like a talk, LLM are growing like even in daily basis. Our news are crowded by all the like different latest news, like OpenAI is releasing new model, new features. Google is releasing new features. Maybe DeepSeek is releasing new features. They are growing rapidly and they are already transforming our work, learning, and creativity. We are, uh, they are very accessible and they are rapidly evolving. So if we can use it wisely, then we can just make our more productive. And for the first introduction section, the takeaway from these slides is like large language models are advanced autocompleters. They are no way near any like self-consciousness robots. But if we want to use it wisely, it's best to ask for information that is fixed or well established, while providing critical content to get the most accurate results. On the bottom end, we have an example saying like, we are mimicking, we human beings are the language models. We want to fill in the blank. Say, a blank, is very happy today. If we have this critical information, both I and today, then the blank should be am because it's the current tense and we have first form I. But if do not have today this bit of information, then the blank can be either am, was, or will because we're not having like a tense information from the user input. It's kind of a little bit different from the which always like generating new information based on the previous one. We're not like masking or like taking a blank in the middle, but the logic is the same. We want to provide critical information as much as possible to make the result more informative. Okay, three levels of using LLM. The first one is prompting. So prompting is basically a single LLM call, which means like we're giving natural language instruction to get AI. It can help with multiple stuff. Its success depending on the clarity and specificity. We discussed it before. And here is an example of giving me 5 we can get away ideas nearly. But a good prompt, I mean, different people can write different requests to LLM, but a good one are usually having any of the following elements. Usually, like we have all of those would be the best. The first thing is instruction. Instruction is a type of task or instruction you want the model to perform. It's more like a description or like you want to control what are the models behave on the high level, saying like want you answer my question and answer in specific format, saying JSON or bullet points or whatever. We can control what the formats of output of the LM. And the content, context is more like the additional information, like external information that can help better to understand your initial question. And the final input data is then the example question saying, give me 5 we can get away ideas nearly. And combining three things together, we can let use LLM most efficiently. Here is example. We have first instruction, present each recommendation as a bullet point, followed by a brief rationale, one sentence only, explaining why it is a good idea, good choice. And the content is, okay, I'm located in RTP area and able to drive. And finally, our question is, list 5 we can get away ideas nearly. So if we just ask the final one, list me 5 getaway ideas, the answer will be in free form. It can be very long. It did contain information, but it can be very long with like you need to search in it. You can just look through all the documents like that GPT generated. But if we have clear instruction and clear content, the GPT itself can filter out those like less practical ones for us and answer in clear format that we instructed it to do. It's like let's saying for the medical practitioners, like they are best instruction followers. if we have our visiting doctor, maybe we just need to write down all the symptoms we have, directly pass them a short note, and they can diagnose based on this. And the same thing is happening with LLM. We need to write down what we want it to do what very clearly. Then the more clear we have, now we ask, the better answer we will get. That's from the prompting. Again, prompting is just one call from LLM. We want to provide as much information as possible. And the second thing is like tool use. Tool use is more like two calls where each one is a prompt. And in this one, the purpose is to enhance the LLM with information that cannot be remembered from its pre-training. Like from the document, it is remembered. For example, the weather for tomorrow or weather for today. It's too hard for any language model, even I believe even in the future, to remember all the future in like both in Celsius and Fahrenheit in all the areas in different times. It's like too many informations to remember. But if we comparing it with a tool and teaching it how to get the weather if it is asked, then this problem is solved. So on the right-hand side, if we pair our question, what is the weather in Paris, with a function called get weather, and the LM can give us the first LM call will give us the response. Okay, we need to do this like get weather function with the input parameter of Paris. And a backend system or we human beings can execute this tool call command that LM generated. We can get this result, append it to our previous questions. And the second LM call will give you the final result, like answering some questions that it cannot be answered purely by itself. And the tool use is like two calls and um, two questions for me on that. First, how can it know how to use how to use different tools? Because different tools have different parameters, have different website locations, but researchers are very smartly to formulate this to call in specific format. I heard that we will have MCP sharing later in this month, but MCP is a very specific format that LLM are well trained on to predict tool calling, saying like what kind of tool that they need to be executed to better answer your question. And this tool execution can be automatic, can manually be executed, but after having that result appended to your original question, can better having more context. Again, just like in for prompting, having better answer to you. And the second thing is to having retrieval augmented generation. This retrieval augmented generation is still like within this tools example. It's also a two hop, like two thing. The first thing, just similar to having a tool calling. In this way, is like we will retrieve one piece of information from our either local or domain-specific knowledge base. It can be a document, it can be just a single sentence. We will append it to our original question. This can be done by a LLM call by similarity search. So LLM or any other like here like information retrieval system on the left can know which tool or which information you need to search. And second, having these two things appended together, the second call will generate the final result for you in a better quality. But this is, excuse me, is the retrieval augmented generation. And tools in general, like two hop calls. And finally, we have agents. Agents is like the hot topic even in large language model domain. It says like can do whatever things that is capable of is usually fall in this domain. But it's not that mythical. It's basically multiple calls. It's like climbing a ladder. The first thing a prompt is having one call only. To use has been two calls. One knowing which function to use, and second appending the function results, answering the question. But agentic AI is more like we are breaking down the user request or user question into multiple like subtasks or sub questions, and for each of them, we are either answer it through prompt or to calling, and we will append it all the results together and give a final result to them. So it will require human or not human LLM to do prompting, to be capable of prompting, to be capable of tool use. And additional thing is planning. Planning is different here. It's like we will need LLM to know how to design its response or how to design its following calls to be better answer your question. Here is a plain example. I like reproduce this figure from a academia paper, but basically the planner is what you just want to say, referred as planning, and the executor is the tool calling. To answer the user query, follow the top contributor of this GitHub project. This is a user request. The planner is basically a prompt that will understood